Alright, so let's take a look at what passive capture options look like in the lab. So the first thing, remember, was reconnaissance. And how do we identify the type of traffic we want to go after, or not so much the type of traffic, but once we've identified our target, we need to know a little bit more about what we want to capture. We can't, it takes a lot of equipment and would not be too stealthy if we wanted to capture every channel in Wi-Fi right now. It just would be. Especially whenever 6 gigahertz get done, and it's just going to be too much. We've got to figure out which channels are in use and have useful information on it. So which channels are in use by the organization where we have physical proximity to do the capture at, and what PHYs are in use. And we can use a couple different tools for that, okay? We can use Windows tools, we can use Linux tools. There's some that are built into the tool we're going to use for most of the passive capture. But there's also a Windows tool that was developed as well. So I'll show you that one here too. A friend of mine, Held Keck, developed a wireless WLAN analyzer utility and made it free for everybody. So that's pretty freaking cool. His name's Held Keck and the tool's called WiFi. So for a free Windows utility, you guys have no idea. to get this type of information on Windows, would have cost thousands of dollars before this tool was released. It is truly an awesome piece of software, and especially for free, man. I don't know why you did it for free, but anyway. So if you look up here, you got the network names, okay? And again, all we're trying to do is just figure out what our target network is going to be, what channels we want to focus on, because we're not, we want to pick out a channel or two. For our demo, we're just going to pick out one because we just want to show you passive capture, how to set it up, and all that. But whenever you're doing your reconnaissance, you're not really giving anything away to go out and do WLAN scanning. Remember, as we looked about, to go out and find these networks, our machine does probe. So you might want to change the MAC address of your machine if you're worried about that. Whatever machine you use to go around the area, you might want to make sure any personal devices that are not set up for pen testing or hacking have the WLAN adapters disabled until you use them, and make sure their addresses, their MACs are spoofed or changed, basically, because you don't want to have any trace that you're there, your devices are there, right? But with a simple tool like this, we can figure out some interesting targets. Now, we've got an SSID set up for our passive capture attack examples where it's bad hotspot, okay? And I want to come down here, and we're going to actually associate to this, because in a minute, we're going to generate some interesting traffic for that. But with our tool here, not only did we scan, guys, but we noticed with the channel utilization, we noticed the BSSID. We could see if there's any stations that are joined to it in this view. Now I have it on the Pro view right now, but there's some other ones as well. Again, we're not trying to check out this tool in particular. It's just, hey, how can we quickly do passive reconnaissance? You can use iPhone and Android apps too. Use whatever you need to, but it can be harder on an iPhone to spoof your WLAN adapter's MAC address. So I like to keep everything separate if I can. Again, this is all passive though, so you didn't really do a lot except send a probe request asking for the WLANs that are available. So you're not giving an awful lot, too much information about yourself being there. And especially during the attack, once we've identified the channels we want to listen on, you're not going to be giving up much then either. I can see that we've got 2 stations now, so that means that this guy's joined as well, and we'll use him in a minute to generate some traffic. But the channel width, that's another thing important, because if I don't have an adapter that supports that PHY, like AC, right? This guy's AC. I want to support AC. If he supports 20, 40, 80 megahertz wide channels, I want to support that as well. We want to have basically feature parity as far as our monitoring capabilities. Not just being able to put the adapter in monitor mode, but if there's clients out there that are transmitting with AC, 2 special streams, 40 megahertz wide channels, and I can't capture that, then I'm going to be missing data frames, okay? It's not going to do me any good. So we want to set up this passive attack for as much success as we can get, okay? The other thing too that you can look out for is, hey, what amendments are we supporting here? For example, this guy's WMM, that's great. It's got K, it's got V. We don't see W enabled there for protected management or anything. So that's good to know as well. But anyway, it's just a Windows tool. It's cool to use. So let's get over to our Kali box and look at another tool that we can use for this. So we're going to be using the AirCrack NG suite a lot. Now, there's a couple different ways to actually put your adapter in monitor mode whenever you're working with Kali, okay? And that's what it has to be in to capture the raw 8 to 11 frames, which is what we're after. So let's go ahead and check out our interfaces, and I'm going to start the network manager just in case it wasn't running. Let's go ahead and do a clear. Now that's not something you would normally have to do, but I was just recording another video for you guys, and I think I had that service stopped. That's the only reason why I did that. All right, so we're going to start off with an Ifconfig, and you can see I've got a WLAN adapter here. Okay, so AirCrack NG is a suite of tools, okay, that runs on Linux, and one of the first ones we want to use is to put the adapter in monitor mode. Again, you can also use native Linux commands to do that, the iwconfig commands. We're going to keep this one simple, so we're going to do airmon ng, and to make sure there's no services impeding the adapter doing capture, we're going to first start off with a check kill, okay? And that makes sure that there's no services impeding the adapter. We can basically, that was the WPA supplicant, for example. Sometimes we want to we want to kill a couple other services too, but again, we'll look at that in a different example. So now we're going to do airmon ng, and we're just going to start WLAN 0. So this puts the adapter into monitor mode. Okay, so you can see we now have adapter in monitor mode, and we support all of our protocols. It's our Realtek adapter that we're using here. Now let's go ahead and clear this out. The next thing we can do if we just want to do some reconnaissance and kind of monitor in Linux what's going on with our WLAN adapters is we can use a tool called AeroDump. Now AeroDump in its default mode is just going to scan all the ISM channels. Okay, it's going to scan all the ISM channels for about 100 milliseconds to 200 milliseconds. I don't remember the exact threshold. And basically it hops from channel 1, 2, 3, 4, 5, all in the ISM band. So we're going to go ahead and start that. And this is just a way, again, I'm listening to each channel to see what's out there, okay? And you want plenty of real estate on your screen because it's going to be a lot of stuff, okay? So in fact, let me restart that with the new screen size. Okay, so as you see, I'm channel hopping. I've got the BSSID here. I've got the beacons. I've got the channel. I've got the the encryption, the cipher, all that kind of good stuff, which is great. Down here, these are all stations, and if the station is associated to anything, it'll tell you which. But right now, we're hopping channels, so we're not going to get the best view of what's really going on. Now, if you remember from WiFi, notice that our stations were already connected to 161, so we could just start monitoring on specifically 161. Or we could scan the 5 gigahertz channels now because this was only doing 2.4. Again, this is just part of the reconnaissance portion to figure out which target we're going to start doing the passive capture attack with. So to do it in 5 gigahertz, we're going to do the same command, except this time we're going to insert the channel flag, or we can do the band flag. So we can do band and do A as well. Now, if we do that, now I start scanning all the 5 gigahertz bands, okay? So all the 5 gigahertz channels that are in there, it's going to start doing the same, jumping between each channel. We're not going to be capturing a lot of useful data in this mode because you're not listening long enough to capture a lot of useful data. So again, all this is about just kind of listening to see who all overall is out there. You'd want a couple minutes to let it get through all the channels, let it grab a few things, and identify our target. We've already identified that the target we wanted to focus on right now was the bad hotspot channel 161. And once we do that, we'll see the number of stations come alive. Again, you're not going to see a lot of stations actually be associated till we've listened longer. Then we'll see the number of data frames and all that kind of start, all those statistics start rocketing up, okay? Especially in busy networks. So now we're going to do the same command, and we know we want to listen on channel 161. You could go ahead and start writing to a file to capture everything, but I like doing this first in kind of a listen-only mode just to make sure I'm seeing those numbers rise, and then I turn on the capture, right? Start the passive capture attack, okay? So we're going to do the same command again, except this time instead of the band command, we're going to throw in a channel flag for 161. So now we're focused on channel 161. And as this happens, as we start generating some traffic with our clients, you should start to see some of this data increase over here, okay? And now I'm seeing more probes and the data that goes with those, right? And I'm seeing more associations, all that kind of good stuff. So because I'm listening to one channel longer, so I'm going to capture more of the actual data, more of what's going on, okay? All right, so now that we see that stuff is good, we're going to go ahead and kill this. I'm going to clear this screen, and we're going to do the same command that we were doing, except this time we're going to write to a file, okay? So this time I'm going to write to a file, and it's going to put it right there in your home directory, and we're going to call this, we'll call this pass. We'll call it passive. Let's do passive cap 2. I think there was already a passive cap 1 that I did for something else. We'll just call it, we'll call it passive cap 2. We'll call it pcap 2. Pass cap 2. There we go. That's something unique. It's going to go ahead and uniquely identify them anyway. You can call it the same name. It's going to put it as a separate number, but this will just make it easier. So now we've got the write command with that arrow dump command. So arrow dump, we're focusing on channel 161, and we're going to write what we hear on channel 161 to this file. And again, it's a listen only thing. We're just writing all the data to a file. So let's go ahead and start that. And the arrow dump tool is nice enough to give us a display of everything we're kind of seeing as far as the 802.11p SSID, the channels, the data, all that. So let's go generate some useful data. So we're going to jump over here to this guy. And remember, we put him on that bad hotspot WLAN earlier. So let's verify real quick what channel he's on. We're going to go to net show, WLAN show interface on Windows. And we see, yeah, he's on channel 161. Great, because that's what we're capturing on. Now, again, normally in this attack, you have no idea what is going to be useful traffic or not coming your way. You're just capturing. You're not in the path. We're not man in the middle. We're simply listening, and we're trying to listen to as much as possible. And so it's kind of like we're capturing the haystack, and then we need to find the needle. But it's still a useful tool, and especially once you have more protected networks that we get into later. And we know those encryption keys, and we can still capture and decrypt because we know those encryption keys. So this is useful in a lot of different ways. It's something you definitely all need to know. All right. So with that said, let's generate some useful traffic. So I'm going to use some unsecure applications here. Let's use, what am I doing, man? Let's use putty. And I have a device here in the lab set up to take some putty request from Telnet. Okay, which is an unsecure application. So we're going to go to this IP, and we're going to put in this username, and we're going to put in this password, and it's not going to work. But that's okay, because I just wanted to generate some unsecure traffic. Well, let's try admin2. And again, doesn't work. But again, if I put in the right password, we'd be able to see that in the logs. We don't want to see that. I just enabled Telnet temporarily. All right. Let's generate some more unsecure type of traffic. So I'm going to open up, don't know what was there. So we'll open up a site here, and let's go to, let's go to a site that uses WordPress. What do you think? Yeah, if it's still running. It may not be running. What do you know? Okay, let's try another site. Let's try my site. Let's do that. chrisevans.com. Got a good login page. Any WordPress site has this, right? And you notice I don't have an SSL on my own site. Go figure. It's bad, I know. It shouldn't be this way, and I will fix that right after this lab. But we're going to see why I need to fix that. And thousands of sites, guys, are like that. So be very careful where you put your information in if it's not a secure site. Just as a side note. I mean, after all, this class is about taking advantage of that, but still. All right. So we hopefully would have captured a lot of stuff. By the way, as we're doing this capture, we're also making tables that we can use later full of BSSIDs. So we know the MACs, okay? We know the SSIDs that are around that are common. We notice how many clients are out there that are probing for things as well. Those are automatically getting recorded through the aircrack dump utility. And it creates several different files, which you're gonna like. But let's go ahead and stop this for now. And I'm gonna clear this out. So we mentioned it puts it right in our home directory. And right here, passcap2 is, and just as I thought, I had a different passive capture. All right, I was showing somebody this in class the other day before we got to recording this class. All right, so we've got this capture now that's written here. And it could be as simple, guys, as just open up Wireshark. Okay, and putting in our file name here. And there is our raw 8 to 11 frames, okay, which is great because, and this is also a way to troubleshoot Wi-Fi, by the way, not just a security thing, but you can troubleshoot 8 to 11 frames in monitor mode very, very easy with what we just did. So it doesn't always have to be from that security standpoint, but again, we are here to compromise people and to attack people. So, and this one is doing it by listening only. All right. So what we want to do is look for some of that unsecure traffic, right? And there's other tools out there, right, that will help you get to the bottom of this stuff faster. But this is one of the best, protocol analyzers. It's free, so you can't beat that. So you can see, hey, we've got telnet commands here coming one by one. Okay, you can see, oh, there's data there, right? So if I look at this, check this out. There's my A. Okay, that was sent. There's my T that was sent. There's my M that was sent. But instead of looking at this one by one, right, you don't want to do that. What we want to do is trace this. Okay, we want to trace this conversation. So we're going to follow the TCP stream. And what do you know? So you could see username. What do you think the username is with that, right? And then there's our password. Very clear. There's username. There's our password. So this is what is so dangerous. And all we did was just listen, right? If anybody was using Telnet on that channel, it's over the air. We could be sitting out in the parking lot, okay? Any unsecure types of traffic. And again, Telnet, HTTP, FTP, TFTP, SNMP, all that is non-secure, okay? Even RTP, phone calls. So if anybody's doing, IP communicator calls over unencrypted Wi-Fi communications, you can listen to it. Now, let's take a look at some other types of interesting traffic we could get from this. So HTTP traffic. Remember, we had a login, right? So if you look, we had some moves there because we went to one site. That wasn't what we wanted, but we also had this other site here too, right? So I've got this 200 OK. So let's see what this guy is. And we can see this was for my blog. Okay, so what we want to look for the good stuff with HTTP is post. Okay, so check it out, post, login information. So HTTP get and post. Get is just getting in the site, but posting is posting some data back to that site. So again, we can follow as HTTP stream. We can look here, so we see the site. We got the header information, all that kind of good stuff. So we can kind of look through all that. Or you can follow as a TCP stream as well, because all the HTML coding and all that's in here too, right? There we go. All right. So you see at this page we had, okay, so we've filled the form WP login. So if you look in there, there is our form item log and then password. Now, searching through Wireshark captures, guys, can take a while. There's other tools that are designed to basically search packet captures and look for username password fields like this. But this is the problem. Anybody logging into anything unsecure, like we said, Telnet, FTP, TFTP, freaking HTTP, which is still very common, as you're going to see us take a lot of advantage of the web stuff, okay? Any of it that's not using active SSL and implemented correctly is potentially exploitable. This one was just listening. There is no real way to go out and trace somebody who collected credentials all day long doing passive capture. This is why so many people are allowed to basically can have a career sitting by a hotel bar, set up capture devices in their hotel room and capture all the hotels around them, just data, just sit there and listen all day and set up little filter scripts to go out and capture username and password fields. I mean, but there's a ton of other, information here as well. You got DNS records and just pretty much all the supplemental stuff that goes along with, packets with data basically. So anyway, it's our first little fun way into getting fun information with this program. I hope you enjoyed it, and we'll see you in the next one.